Quad 66. In this video, we're going to be looking at some black box data from the HDZero AIO15. This is a new board from HDZero. I showed some flight footage and some camera quality from a previous video on it. But this board allows 2 to 3S builds with the 15 amp ESCs. So you can get some punch out of it, but you can't like build crazy with it. It's got HDZero integrated in. It also has Express LRS integrated in. And I'm running it with the Lux camera. You have the options of either the Echo or Lux camera, and I'm not really sure the purpose of the Echo camera other than saving some weight, because the picture quality on Lux is much better. With this board though, unfortunately there is no black box built in, so I had to use external black box. The one I'm using is the Airbot Open Logger. An SD card slides in here, and so that should kind of give you a sense of the size of it. And then what you do is you go ahead and wire it up to one of the free UARTs. Now, this has some size to it, so when we're doing these lightweight builds, you are adding some weight, and you're also sticking that thing to the surface of the board. So I'm using two-sided tape to stick it just right to the surface. And hopefully that doesn't throw things off too much in terms of weight or potentially like creating some vibration or even damping vibration. The other thing it definitely does is it blocks airflow, so the board's a little bit more prone to heat up on you. But that's pretty much the best you can do when there's no black box built in. In terms of the build I'm flying it on, this is sort of an example. The frame I'm using is this one here. It's the Warpig 114, meaning 114 millimeter motor to motor mount. And it's got this TPU canopy. I've got a slightly bigger camera with the Ant light. And I've got two versions of it. I've got an analog build, which is basically this one with this Flywoo board. It's got an MPU6000, external VTX, external Express LRS. And then the motors are updated from these. They're updated to the 1104T motors, 7500 kV, and GemFan 2520 props flying on 2S with a 550 battery. So that kind of gives you a sense of the build. And so obviously with the HDZero build, it's got the HDZero board in here with the open logger sitting right on top. In terms of the data, getting into it, so because I had that analog tune, I already had a tune kind of roughed out a little bit. And so this is from the analog build. And what we're looking at here is the tracing. So on this one, what I have set up is the set point for roll and pitch, and then the gyro for roll and pitch. And so what you want to see is this gyro line, the red line, really following the set point and staying really close to it. And you can see that you've got a pretty good just that here, where this gyro is following it pretty well. This tune is a little bit soft, where you can see a little space there, a little bit of softness there, but overall looks pretty good. And if you go over into the twitch moves, so these are the big snap rolls. So if you're not really familiar with this, this is a full on, full speed roll, and then full off, so a snap roll. And then the other thing you look at is your twitch moves, which kind of gives you a sense how it's going to do on the smaller, quicker, I shouldn't say quicker, but just smaller stick movements. And those are these here. And so what you want to see for a tune is, again, the same thing, that the gyro is kind of sitting on that set point and matching it well. And this right here, looks pretty good. It could get maybe a little bit more aggressive, but not too much more than that. The other thing you want to look at is to see if you have any oscillations. So these are punch outs here, these 3 peaks down there. And what you can see is just a hint of a little oscillation coming in, but nothing bad at all. And when you're flying the quad sounds very clean in the air. It sounds good. It doesn't sound like it's oscillating. So this isn't like a done, 100% done tune, but it's pretty good. So what I did is I took this tune and just threw it onto the HDZero board. And I was really curious to look at it because with the HDZero board, this board has an ICM gyro, and I've never flown an ICM gyro, so I was curious to see how it would compare. I've done MPU6000s and BMI270s and pretty familiar with how those boards kind of differ and what you need to do in terms of the tunes. So just starting with this, kind of take a look at some things. Some things kind of jump out right away. One is that the tune is not far off, but things look a little bit funny, a little questionable. One of those things is that if you look at our set point, this does not look quite as smooth as that other build. So that other build's a flywheel board and external Express LRS versus the HDZero built-in Express LRS. It is via UART, but it is kind of baked into the board. And what you can see on that set point is it's not as smooth. Let's go back to, let's get these right next to each other. You can see just how smooth that is. So that's something to dig in, and I'm going to dig into it in a little bit here, but that was kind of something that seemed a little bit odd, kind of off the start. And then also when we kind of get into the twitch moves, let's find some of these. They're not bad, but they're not hanging on quite as well as they were with the MPU6000, which is kind of surprising because these builds are actually the same weight, same powertrain. Really the only difference is the board. So it's kind of interesting to see that much of a difference in how the twitch moves looks just essentially from the board. Now the motors are different, but I tried to normalize that out. I tried to, like the motors on the HDZero build, they were not new. And so I did kind of swap out the worst bell to try and kind of even them up a little bit. But you can just see some differences jumping out at you. So digging into the set point, why is that set point so rough? That was one of the first things I took a look at. And so let's look at our RC command. Let's do that for both of these. So now what I have in yellow is the RC command. This is the unfiltered signal coming from your radio to the board before you do anything to it. And so this is simply what is the quad seeing, or what is the CPU getting from the receiver? And you can see that that's quite different. If we zoom in, we can see why it's different. And the reason I'm zooming in here is because we're going to measure the steps on these. So I'm going to take both of them and I'm going to zoom in now. So with Express LRS, I am running 500 hertz, and so that's how these should measure out. They should measure out at the frequency that you're running. And so if we go ahead and measure out one of these steps, we can see that once we measure it out, sure enough, 2 milliseconds, about 500 hertz. Let me get that kind of right on. So about 500 hertz. And on the external Express LRS with that flywheel board, you can see that each step is very consistent. It's 500, 500, 500, like it's boom, 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 all very consistent. And that's true pretty much scanning through like most of the trace. Like I'm going to kind of scan through this with you. But you can just kind of go through it, and in general, that's what it's doing. It's staying pretty consistent all the way through. And so that's good. That's what you want, because throwing a bad signal in there is going to cause all kinds of problems before you can even start dealing with the PID tune. If you look at now the lux, you can see what it's doing here. Let's measure some of these out. So I shouldn't say the lux camera, I should say the all-in-one of the HDZero AIO15. So here, right, we've got 2 milliseconds. Okay, so that looks good. But then let's measure the next one. And then now we've got 4 milliseconds. Let's get it about on 4 or 5 milliseconds. And so what's happening here is it is not getting all of the packets. Like, it's sometimes getting the packets and sometimes it's skipping them. And so it's varying back and forth between 500 and, so in this case this was like 3 packets. See how this is each packet, the step should be 2 milliseconds, but in this case it's 6 milliseconds. So that was within the time frame that we should have gotten 3, we only got 1. And what that means is that we're kind of like generating this sort of like artificial jaggedness to it, and this causes a lot of problems with your feed forward, and you kind of like over smooth, under smooth, and kind of makes a mess of the traces. In terms of why that was happening, one of the things that's contributing, it's not the only thing, but one of the things that's contributing is the antenna. I had it kind of untucked under, kind of like tucked away a little bit safe, but maybe a little bit too close to some of the electronics. And so then what I did is I took the antenna and I pulled it out straight up outside the canopy and away from like the VTX antenna, away from everything else. And lo and behold, that really improved the consistency. Unfortunately, though, although this looks really good right here, right now we're like on these really consistent steps. You can see I just zoom in there a little bit to show you. These look really good. Like here's one, missed one, but the rest of them look really good, right? You know, so although that helped, it didn't fully resolve the issue. Definitely made it a lot better. And so I think that's one of the things with boards, I don't understand. I mean, other than how tight everything is crammed in here, and maybe they just didn't have room for black box, but short of that being the reason, I think at this point in time, like you just got to put black box on these boards, because I think there's some of these performance issues that you just have no idea. Without black box, you'd have no idea. The quad would just not feel quite as good as it could, and you'd have no idea why, and you wouldn't have the ability to dive in here and figure it out. And in this case, it was something as simple as moving the antenna made a dramatic difference. And let me show you just how dramatic of a difference it actually translates into. So let's go to our tracking. Yep, tracking here. So before moving the antenna, let's look our tracking. Here we go. So kind of before, let's go to these step moves, these little twitch responses over here. Oh, that's why they look good. It was the wrong board. Let's go to our all right, so here's our HDZero board. It's kind of baselining, and so here's your twitch moves here, and this is basically I'm doing the same move. The difference here is really it's really in how the quad's picking it up, and I think here's a really dramatic example. So through here, compare that to this, just moving the antenna. Let's look at the twitch moves here. You know, not perfect, but much, much, much better. Like, right? Much better just by moving the antenna. Let's see. So, you know, poor antenna placement and good antenna placement. So a pretty big difference there. So that's one of the things that jumped out right at me is that the antenna placement on this is pretty critical to make sure that you have this. But even with the good antenna placement, this wasn't necessarily perfect in some of the traces where you know, the antenna gets bent a little bit or something like that. It definitely kind of fell off a little bit, versus if you have it like in a really perfect position, you get much better traces out of it. So I think that's one of the things for HDZero to kind of look at, is to think about maybe a better solution than this very bendable, you know, wire antenna that you kind of want to keep it out of harm's way, but trying to keep it out of harm's way might be working against you. Or there might even be some stuff within the board, the way they're implementing things that might not be, that might be working against them a little bit. All right. So that's kind of issue one. Issue two is not really so much here, but once I started tuning this board, trying to push it a little bit, because you can see it needed a little bit more, but as I tried to push, you'd start to get some P oscillations here. So at this baseline tune, there wasn't much, so that was okay. But in terms of figuring out how to tune this board, then let's look at our noise. So we're going to look at our gyro scaled. on the roll and gyro scaled on the pitch. And these are going to look pretty similar between these. The gyro itself, okay, let's pull up gyro scaled here on both of these. So here we've got the MPU6000 board, and then here we've got the ICM board, so the HDZero. Nothing looking too dramatically different right off on the gyro scaled. So this is the raw, unfiltered gyro data coming in from the board before we filter it. And so that's on the roll axis. Now we'll go to the pitch axis. And so on the pitch axis, you can see a little bit more signal there. The other thing we see is, so on the MPU6000 board, this area kind of looks nice and smooth and clean, and no problem spots here, versus we got a little problem stuff here. And I kind of go through, I swap some frames and do some things to see if it's kind of more in the board or more, where's that coming from? Because this low frequency kind of stuff tends to be problematic. The first thing I dug into is starting to think about our RPM filtering. So this is frequency versus throttle, and this kind of shows the brighter this is, the more noise there is. And what you can see, let's see, this is on gyro scaled roll. So on the roll axis, you can see how our noise is really dominated by this first motor harmonic. There's maybe a little frame noise there. Nothing too bad here. This is a little bit of concern right there, but nothing too bad down low. The reason this stuff gets concerned is down low, you have no filtering down here. You can't filter, so anything that's down here is just going to go through and cause you problems. And it can contribute to like oscillations and things like that. So what I see here is, kind of usual thing with tri-blades. It's kind of real dominant band here. And then this one, after kind of playing with it, figured out that this is the third harmonic, and the second harmonic is kind of living right in there. And overall looks pretty similar, other than that kind of low area I was mentioning, to the MPU6000 board. Kind of show you similar there, that again, kind of dominated by that first harmonic, but you see more of that third harmonic on the ICM board versus the MPU. So here's MPU6000, and then the ICM board, you're mainly seeing more of that third harmonic coming in. So to figure that out, though, I wasn't sure which harmonic it was off the bat. And so what I did is I went ahead and used the your ability to kind of weight the filters. So in this case, on the RPM filter, I went 100 on the first harmonic, 1 on the second harmonic, and 100 on the third harmonic. And then we can see what happens when we go now to the D term to see what's coming through. So I'm going to use this 100, 100, and then this one I've got set up 100, 100, 1. And this will allow you to see the difference between the two. Okay, so this is 100, 1, 100, and then this is 100, 100, 1. Make sure I'm on the D term in both cases. So D term there, on roll in both cases. And so the difference that we're really looking at here is so we're applying the same amount of filtering to the first harmonic, and then what we're really looking at is how the second and third harmonics contribute to the noise. And so when we filter that third harmonic heavy, how much help do we, how much good does that do versus if we filter the second harmonic heavy? And so what you can see here is that if we filter that second harmonic heavy, we kind of clear out this patch through here, but we let all this noise in on the third harmonic. And if we compare that to this case, if we let the second harmonic in, it is here, but we're getting more benefit out of filtering that third harmonic. So what I settled in on then was a little bit of a strategy of filtering all of those harmonics, but focusing, kind of balancing them. And I'll show you what I did here. Let's get that D term. And this is on roll, just to keep it consistent. And so what I did here is ended up with saying that I put 33% of the filtering effect on the second harmonic, so I dimmed it down to 33. And then on that third harmonic, went to 66, and that kind of gave us a sort of balance in terms of covering all of them and kind of balancing it out. So my thought on it is that you kind of want to bring them all down to sort of like the same dimness, and there's sort of like a response curve. So if you do too little, you basically left easy, like as you add filtering, you're going to add some delay, but you're trading that off with decreasing the noise. And so if you underfilter, you're going to like only get a tiny benefit in the delay, but you're going to get a lot of noise in. If you overfilter, then what you're going to do is only get like incremental increases in the filtering, but you're going to add a lot of delay. And so I thought this strategy with 100, 33, and 66 was good to kind of balance out the noise from all the RPMs. So that was a little bit different than the strategy I had on the I forget exactly what it was on my MPU board, but it's a little bit different. And in the later ones, I know what it is, so I'll kind of show you that comparison, a direct comparison from the MPU6000 to the ICM once all the filtering is done. All right, so I kind of worked through that. And then the next thing I worked through was, so let's kind of put these away so we don't keep coming back to them. Okay. So the next thing to work through was how much the D slider is going to help us. And in this case, what I was seeing is after I kind of dialed in that RPM filter, we still had a ton of do you see all this just like kind of across the board? We just had a ton of noise just kind of broadly across the board. And when you have this kind of broad, non-specific noise, this is where your low-pass filters come in, because your low-pass filter just kind of broadly cuts across, and it doesn't target anything. All it does is it increases as you go up in frequency. That's all your low-pass filter does, is it filters very low, very little down low, and increases as you go up. And with this broad band of noise, this is just kind of screaming out at you, hey, put some more D-term filtering on that. So that is what I did. And so in this case, what we went from is on this one, you went from a D-term slider on the filter of 2 and just pushed it up to 1.5, and that increased that D-term filtering. And you can see for not really a lot of penalty, if you just take my word that it's not a lot of penalty, you got a lot of benefit. So just going to 1.5, you really took out a ton of that noise, and it really helped clean things up quite a bit. So that was good. I thought that was well worth it. And so on this ICM board versus the MPU6000, I think like a D filter on that slider around 1.5 is probably a good idea. And that's sort of a known thing, that the ICM is just sort of noisier across the board than the MPU6000. And so that kind of fit with what we sort of know from it. The other part I want to see is how much work are the dynamic notch filters doing. So in this comparison, let's go ahead and get our noise again. So this is back to that D term of 2, but I'm doing that because I want to show you specifically the effect of the dynamic notches. So my usual is kind of running 2 dynamic notches and running them with a wide Q factor, running them with a Q factor of 300, and also giving them a kind of wide range to go after stuff too. And so let's see. It's going to be determ roll and determ 1 harmonic. Okay. So in this case over here, we're running 2 dynamic notch filters. So the dynamic notches, they're kind of V-shaped, so they kind of cone like this, and they're allowed to kind of run around. Wherever they see a spike, they kind of try and jump on it, but they're a little slow. They sort of lag, and that's why I think you have to run them kind of wide so they basically get there in time. Is how, I don't know if that's exactly technically right, but that's kind of how I picture it. And so now here we see the difference between 1 and 2 dynamic notches. So this is 2 dynamic notches and then 1 dynamic notch. So you can see if we try and cut a dynamic notch, it makes a pretty big difference. That's a pretty big loss of control of that noise. And so again, in this case with the ICM filter, with the ICM gyro, unlike the MPU6000 where sometimes I would get away with 1 dynamic notch, I think having 2 dynamic notches similar to the BMI 270 works nicely for or it's kind of needed for the ICM gyro. Let's see. The other thing I wanted to see was then narrowing the Q factor. Okay, so let's clear some of these out so I know where I'm trying to go from here. Okay. All right, so now what we're going to do is look at trying to narrow down, we're going to try and narrow down the Q factor on the dynamic notches, and we'll see the effect that that has on it. So again, I'm going to pull this up, and so we're going to go our determ roll. And so determ on roll. All right, so now I've got the regular Q factor that I like to run, which is 300, and then I tried to narrow it down to 500. And so not as dramatic as some of the other examples, but still, you can still see that in terms of filtering 300, you're going to give something up. So if you narrow down, try and save some latency, if you narrow down that Q factor to 500, you're still giving up quite a bit of control in terms of that noise. And so then the question becomes like, okay, then when do you make that trade-off? Like, how do you know? Like when to go with the shorter, with a smaller Q factor and decrease the latency? And the answer is I think there is no great answer, but what you look for is signs that the latency is causing you some problems. And one of those ways to look at is to see if you look at your gyro scaled. If you look at the gyro versus the gyro versus the gyro scaled, how much latency is there between the two? So we've got gyro roll and gyro scaled. So let's zoom in on this here, right? And so this is going to be running the wider Q factor, and there's just not a whole lot of latency here. So this gyro scaled is leading the gyro filtered by barely anything. If you try and measure this out, it's hard to even find like a big enough gap to sort of measure it out. At most, it's getting maybe into like a millisecond range, maybe something like that in terms of seeing a gap. It's just not much there. So I think we're perfectly safe with the amount of filtering we're running. We'd have to run quite a bit more, I think, to generate significant latency. All right, so with all that in mind, then I kind of went to a sort of fine-tune, kind of went into fine-tuning things. And so what I did is I said, on my analog build with the MPU6000, I dialed some things in a little bit. Some of the changes were I pushed up my master slider a little bit, but I dropped the D term balance down just a touch. And the reason I did that was to get these to where I wanted to see the gyro here just leading these just a tiny bit. And so if you decrease your that balance, if you have more feed forward versus D term, as you pull that D term down or push that feed forward higher, this is going to start to cross over just a little bit. And that's right where I like to get it, where it's just leading a tiny bit. And part of the reason to keep the D term down is it can cause you some problems with the oscillation. So on my analog build with the MPU6000, you can see I kind of pushed this. It's starting to bring just a hint of the trilling out. And also on the filtering, I went ahead and used the same filtering strategy on both boards. And this is the results I ended up with between the two boards. We'll kind of compare them a little bit and compare just basically, the MPU6000 versus the ICM. So in terms of when do you push that balance too much? So for example, if you get carried away with the feed forward, what's going to happen? So when you get carried away with the feed forward, your step or your snap roll is going to look fantastic. So you're going to basically have almost like perfect set point tracking on that snap roll. But the time when you know that you've got too much feed forward or P versus your D term is now you're going to start to get leading of that gyro. So here you can see the red gyro. It's stepping out ahead. It's like crossing over and stepping out ahead and leading the set point, which means that your quad is now like over anticipating what you're doing. And so this is too much. In terms of how big of a difference is that, it's not much of a difference. So here, what I did was I pushed up the feed forward a little bit. I think I went from 1.25 on this slider to like 1.5, and I took the D term from like 1 to like 0.9. And so it wasn't that big of a difference, but it was enough to sort of bring that out. And that's how, like, what you want to do is when you're tuning, you do want to push this far. You actually want to push it too far to see where too far is. Sometimes what happens is, unless you like really confirm that you're too far, you're actually undercooking it without realizing it. But in this time, I kind of kept pushing until I confirmed that, yes, this is too far. And so that kind of validates that where I was a good place to be. Okay, so now let's compare my fine-tuned analog and my fine-tuned ICM. So here's the ICM. Let's go ahead and start with the tracking. Let's look at the tracking between the two, and we'll compare them. All right, first thing to look at the tracking is to see, are we getting any kind of like oscillations? And so this is on the MPU6000 analog build. Just tiniest little hint of oscillation there on these like punch outs. So these are high, like mid to high throttle. You can see again, just a little bit of that oscillation creeping in, but nothing bad. And when I fly this quad sounds excellent. It sounds clean, really clean in the air. Sounds really good. And then on the snap rolls, I'm gonna look at here. I think this one's a little bit better. The snap rolls, we're coming across and holding it pretty well. Looking really good there. Again, this is the analog board. And then our twitch moves, again, we're tracking set point really well through the twitch moves. The gyro is maybe just a hint of it getting ahead, but not really. It's just you can barely see it starting to get ahead. So that's like pretty ideal. And so that's a nice balance where we're on the edge. Like, when we're on our punch outs, we're right at that edge. You go any further, you're going to start bringing in a lot of oscillation. On our snap roll, it's maybe just a touch soft for the snap roll, but that's what you have to, because if you go any more aggressive with your tune, then you're going to start to step ahead on your twitch moves, and you're balancing the three of them. So that's kind of a good kind of like baseline to compare to when we look at our ICM build. So this is the HDZero now, the ICM. And what you can see here on this is the same exact tune. We're just seeing more oscillation. This isn't bad, but you can hear it. It's not really going to affect the quad's performance much, and you're going to waste a little bit of energy. But mainly what you're going to do is you're just going to hear it. You're going to hear this little oscillation. So like when you punch out, the quad's not going to sound clean. And you are going to waste a little bit of efficiency there. But you can see it consistently. These are the punch outs here. And in each case, as you kind of go into the punch out, I'm getting a little bit of that oscillation. In terms of set point tracking, on the snap rolls, looks good. For whatever reason, it just was never quite as clean holding the max rotation rate. I'm not sure why, but it jumps on the set point a little bit there, a little bit bobble off the end, but nothing bad. I mean, these honestly look pretty good. Like, these are pretty dialed in, so I've nothing really to complain on those snap rolls. And then on the twitch moves, not quite as good as the MPU6000, but very good. Like, it's where it's where you want to be. Like, it's barely just starting to hint that it's trying to get ahead there. You're losing a little bit of control over the top. You could pull that in more by pushing up the master slider, but when you push up that master slider, then you're going to get more P oscillation. And yes, you can try things with TPA, and there's all kinds of things you do, but you end up so far in the weeds. And it's kind of like squeezing a water balloon. Anytime you squeeze in one place, it's going to bulge out someplace else. So, if you're trying to like second guess and say, hey, I can fix this up by doing this, then you got to look elsewhere to see where you're causing a problem. But anyways, that's a pretty decent tune. My main concern about it is this particular trace didn't have a lot of examples, but it's mainly the roughness that occasionally sometimes comes out in the set point. It's not often, but it's coming out enough that it's a little bit concerning that every once in a while our set point's getting a little rough, like we're losing some packets along the way. But as far as the tracking though, I think that's a pretty decent tune. Main complaint with it is just I'm getting a little bit of oscillation. Maybe if I put clean motors on it, maybe that would take care of it. This is the same frame. I actually swapped frames to make sure that it wasn't like a softer frame that was causing the problem. So I did everything short of resoldering and swapping all the motors over to make this kind of as fair of a comparison as possible. So then looking at, let's look at the noise. The noise here, like in either case, the motors aren't getting hot, so you don't really have to worry too much about the noise. The main reason to kind of think about the noise a little bit is just kind of for the sake of efficiency. So the more noise you have, the less efficient you're gonna have. But going through the analog to MPU6000 build, one of the things I think about with the D term is, do we get, with like my little throttle blips, do you get too much of these little blooms of D term? This is a little D term. I don't know what people call them, but I call them little blooms, where as you're kind of going through the throttle, it sort of blooms up on you. And then also you want to look for these areas where you get these hints of a little bit of like kind of oscillation there, where these like kind of, you can see that it's not random. It's kind of like sinusoidal there. And so that kind of tells you, where you're at from scanning through it. And then you also go ahead and look at the plots. And so we'll compare a D term on these and pitch as well. So let's go ahead and look at that also. So this is now on the ICM board. And actually, let me go back to here in the punch outs. Yeah, so kind of leading into these punch outs. So this is the MPU6000, the analog, and then here is the punch out leading into the ICM. And you can just see on the ICM board, there's just a little bit more of that D term kind of blooming up there, a little bit more of that oscillation. And then similarly, see like these little throttle blips on the ICM, getting just a little bit more of these, D term kind of blooms. Nothing terrible though. Mainly probably a little bit of flight time, but you can hear it a little bit. And I think it does kind of bother me a little bit that I can hear it. It kind of annoys me. So now, let's see. So same tune, same filtering, MPU6000, ICM. So this is on the D term roll. The more color, the more redness you have here, the more noise you have. Easy to interpret. And these sliders, I'm not moving them any. They should be the same. And to tell you also, my tuning flights, I have a very methodical flight. Like I've done it so many times. It's 1 minute and 30 seconds long. It does the same thing, and it's very consistent. So I'm pretty confident I generate about the same amount of like flight time and maneuvers between the two. And so this is really just down to the noise that the board is ultimately seeing. Looking at pitch. So this is the MPU6000. This is the ICM, analog, digital. So MPU6000, ICM, flywheel board, HDZero board. Just essentially what you're seeing is just more noise. It flies fine, but this is going to cut a little bit into flight time. And I think I am seeing that because I was noticing getting probably like 30, 40, maybe more, 34 seconds less, maybe even more, when I was flying the two boards back to back. So it does make a difference. Maybe not a ton in how locked in the quad is, but definitely in how it sounds, and probably also in flight time. Last thing I looked at is I'm a big fan of like strapping the battery down really tight and using that as a damper. And so one of the things I have here is a little example of comparing some noise with using a little TPU to strap down the battery versus using a battery strap. And so this is without a battery strap, using just TPU. And this is adding the battery strap. So some grams, but you can see how just going from this, where you're letting that, you're not using, I don't think this is generating noise per se with the battery flopping around. Maybe this spike in here, so see that bright spot? Not mounting the battery rigidly enough maybe contributing to this kind of wobble, that little bright spot there. But overall, when you strap that battery down, you can just see how it just dampens the noise across the board. So I think the battery is one of the least thought about filters that you have available. It's one of your most effective mechanical filters along with your frame. And that's a little bit of an example there of how that filtering difference. And so now this is on the pitch axis, comparing the two. So with the battery strap, without the battery strap. Now let's go back to roll. Let me make sure I'm comparing apples to apples. Yeah, so here's roll. Roll without a strap, roll with a strap. And let's make sure I'm comparing pitch. Let's make sure we're comparing the same things here. So pitch. So this is pitch without a strap, and this is pitch with a strap. All right, black box. I think going through, and I've spent literally all day yesterday and all day today going through all this stuff, checking all these like variables, and um, I still have a little bit of doubt, like how much difference does that using that open logger sitting on top of the thing versus integrated black box. But I think some of the differences that we're seeing here really highlight the need to have black box on these boards. If you've made it through this far, good for you. This has got to be like a pretty one of the longest videos I've done in a long time, I think. But I think it's worthwhile, hopefully, for some people to kind of see this. And this is also when when I do these builds, I spend so much time going through this to make sure that at the end of the day, if you build up one of my frames and follow one of my builds, you know what the issues are, you know how to tune it, and you know you're going to get something that, that flies well. So kind of just leave you at the end here with sort of like, here's the proof, here's the black box proof. If you build it up the way I say, I suggest to build it, and you follow my tune and everything, then you can very likely expect it to look like this with like, very, very, very good set point tracking and, keep the noise in check. All right, till next time, cheers.